Hello, we are covering 5.1 proving identities here. Okay, so this here is will help you when we start doing like simplifying and solving trig expressions and equations. Uh, so make sure you take notes and you're keeping up with the homework assignments. Okay, and checking in for attendance. Okay, so 5.1, proving identities. So what we're going to be doing here is we're going to be given an identity, an equation, and what we need to do is um, verify that they are equivalent. Okay, so we have some basic identities that you guys are aware of. Basic identities. So let's go over those. These are those reciprocal identities. So, like, we know that sine theta is 1 over cosecant. And we know that cosine theta is 1 over secant. And we know that tangent theta is 1 over cotangent, right? And then same thing with the other way around. If we have cosecant, we know cosecant is 1 over sine. And we know that secant is 1 over cosine. And we know that cotangent is 1 over tangent. Okay, so it's important that you understand that whenever you see a reciprocal, when you guys are proving these identities, and when you see a reciprocal like 1 over sine, that you change it to cosecant, or if you see 1 over cotangent, you can switch it to tangent. Okay, so generally, not always, but most of the time, whenever we do see a reciprocal like this, this 1 over trig function, we try to rewrite it the other way. Okay. Not always. Sometimes we want to go the other way so that we can get something else. But like when we do simplifying, if you do see something like this, simplifying will come in a few sections. But when you see like a 1 over a trig function, then you want to rewrite it so that it's not this fraction. Okay. All right, and then we also have the so these here are the reciprocal ones. Okay, reciprocal identities. And then we also have the basic identities for the tangent ratios. Okay, so basic identities. Our ratios here, and that's for the tangent and the cotangent. So we know, aside from these reciprocal ones, we know tangent is 1 over cotangent, but we also know that tangent is sine over cosine. And since cotangent is the reciprocal of tangent, then we know that cotangent is also equivalent to cosine over sine. Okay, so we have these basic identities, and then we have the Pythagorean identities. And we covered the Pythagorean identities early on. Pythagorean identities. Okay, so we have 3 of them. We have sine squared plus cosine squared equals 1. Okay, so we have this one here. And then if you remember, if we divide everything here by cosine squared, if we divide this by cosine squared, then we end up with tangent squared. If we divide this by cosine squared, we get 1. And if we divide this by cosine squared, 1 over cosine squared is secant squared. Okay, so that's the second Pythagorean identity. And the third one, you can also derive that one so from the first. So we got the second one by taking the first Pythagorean identity and dividing it on both sides by cosine squared, right? Because sine squared over cosine squared is this. Cosine squared over cosine squared is 1. 1 over cosine squared is this. Okay, so we get the third one, the third Pythagorean identity, by taking that same first identity right here and dividing it now by sine squared. Okay, so if I divide this by sine squared, I get 1. If I divide this by sine squared, I get cosine squared over sine squared, and that's cotangent squared. And then if I divide this by sine squared, 1 over sine squared is cosecant squared. Okay, so these are our 3 Pythagorean identities. And what we're going to be doing is we're going to be using all of this information that we just wrote down. We're going to be using all of these here to prove some other identities, some more complex identities. Okay. All right. So how do we do that? Okay. So proving or verifying identities. Okay. So we prove or verify identities. So you'll be given an identity, so an equation. So you're going to choose one of the sides, and you're going to choose one side to rewrite. Okay, and usually the more complicated side, the more complex side. If they look equally complex, then just choose either one. All right. And then once you choose a side, then you're going to go ahead and rewrite the chosen side. Rewrite chosen side using above identities. So all of your basic ones and your Pythagorean. Okay. And you stop when chosen side looks like the other side. Okay. So we're going to be doing a bunch of examples here. So let's go ahead and start with this first one. Okay. So for example, suppose that you have to prove that sine theta cotangent theta equals cosine theta. Okay, so these two things equal each other. So we have to prove that. We have to show that it does. Okay, so we're going to follow these steps right above here. Okay, so the way we prove this is we choose one side to rewrite, usually the more complex side. So I'm going to go ahead and choose this side, definitely a lot more complex. Okay, so let's go ahead and choose this side. And then we're going to rewrite that chosen side using the above identities. Okay, and then we're going to stop when it looks like this, the other side. Okay, all right, so I start with the more complex side, sine theta cotangent theta, and then I'm going to go ahead and rewrite this using the identities that I have above. Okay, so I'm going to go ahead and keep the sine theta, but cotangent could be written as cosine theta over sine theta. See how I did that? Okay, so Now here, the sine thetas will cross cancel, and I get cosine theta, and lo and behold, it looks like the other side. So this is when I can stop. Okay, so that's how these work. You choose one of the sides to rewrite, usually the more complicated side, because if you choose this side, you're going to have to somehow use the above identities to get this to look like this side, and that's much more difficult. Okay, it's easier to take this side and simplify it. Okay, so once we chose a side, then we go ahead and use the above identities and try to simplify it until it looks like the other side. Okay, let's take a look at another example. All right, so let's prove that tangent theta over secant theta equals sine theta. Okay, so clearly the left side looks more complex, so I'm going to go ahead and choose this side. All right, so tangent theta over secant theta. All right, so here, what I'm going to do is I'm going to separate them. So instead of writing it like that, I'll write it like this. This is equivalent. If I multiply this, I get that. Okay. And then 1 over secant is 1 over secant is cosine. And then tangent theta is sine over cosine. And remember, we're trying to get to sine, okay? Tangent, I'm going to rewrite that as sine theta over cosine theta. And I'll bring this down. And then here, I see that I can cross cancel cosine theta. So I'm left with sine theta, which is the other side. So I can stop here. Okay. All right. So again, here I chose this side. I separated them, and then I used my reciprocal. I used my reciprocal identity to rewrite this as cosine. And then I used my ratio identity to rewrite tangent as sine over cosine. And then I canceled. Okay. All right, let's try another one. Prove tangent x plus cosine x equals sine x secant x plus, let me rewrite that, plus cotangent x. All right, so they both look kind of complex, both sides. So, just pick one. You could probably take this and somehow manipulate it until it looks like this. I think I'm going to go with this side. Okay, so, but you could go with the other side. So I'm going to go ahead and choose this one. Maybe you can at home choose this side and see if you can get it to look like this side. All right, so let's see. Sine x times secant x plus cotangent x. All right, so oftentimes it's a good idea if you have several different trig functions involved. Oftentimes, not always, but oftentimes it might be easier if you try to change everything to sines and cosines. So let's see. Let's try to rewrite this. I'll keep this one, but secant is 1 over cosine. And cotangent, let's see, what are we trying to get it to look like? Okay. Cotangent is cosine over sine. Okay. And okay, so here, if we're trying to get it to look like this, tangent is sine over cosine. So I'm going to go ahead and multiply my sine x. If I distribute the sine x, I get sine x over cosine x. That's going to be my tangent. And then when I multiply sine x over here, they cross cancel, right? Here, let me do it one step at a time. So I get this, and they cross cancel. Okay? So now sine x is tangent. And here I'm left with cosine, and this is the other side, tangent x plus cosine x. So I can stop here. Okay? All right, so hopefully this is making some sense. It really helps to know, the identities, the basic ones. Okay, so let's try another one. Okay, so let's go ahead and prove cotangent x plus 1 equals cosine x times cosecant x plus secant x. Maybe try this one on your own, see if you're able to do this. Okay, and then come back and see if we might not have the same work. So long as I'm going to choose this side. So if you want to choose this side and then see if you can get it to look like this, give it a go and see if you can get to this. Okay. If not, if you get stuck, then just come back and watch this. All right. Okay, so I'm going to go ahead and choose this side. It doesn't matter which side you choose. They look kind of equally complex. This one a little bit more. Cosine x times cosecant x plus secant x. Okay. So I'm going to use what I did in that last problem, and I'm going to try to change everything since I have like 3 different functions here. I'm going to go ahead and rewrite everything in terms of sine and cosine. Okay. Cosecant is 1 over sine. Secant is 1 over cosine. And then I'm going to go ahead and multiply the cosine x. I'm going to go ahead and distribute this to everything inside the parentheses. When I do that, I get cosine x over sine x. And here I get cosine x over cosine x. And then cosine over sine will give me the cotangent that I need. And cosine over cosine will give me the 1 that I need. So here I can stop. Okay? All right, so hopefully you got that. Here are some guidelines to help you out as you do these. Guidelines for proving. I already told you some of them, so let's just write them down. Okay, so we're going to choose the more complicated side. Choose more complicated side. And then start with using basic identities. So these are the ones that we wrote down at the very beginning of the lesson. If there are squares, like cosine squared, sine squared, tangent squared, secant squared. So if there are squares and or ones, try using the Pythagorean. That's when those come in handy, when you start seeing squares. Try using a Pythagorean identity. And remember, we have 3. That's the sine squared plus cosine squared equals 1, the one with tangent squared, and the one with secant squared, etc. Okay. And then try changing everything to sine and cosine, especially if you have a lot of trig functions in your identity. Okay, so try changing everything to sine and cosine. Okay, and then always keep track of what what your end result should look like. So keep your goal in mind, because it's very easy to to just keep going all these different directions, and you just keep doing these things, and it's like, okay, um and they're very random, and at the beginning it might feel like you're just choosing these sort of random directions, but at some point you should be getting closer to what your goal is. Okay, and again, your goal is to get it to look like the other side. Oops. All right, so let's take a look at some that might be a little bit more complex. Okay, so let's take a look. Let's go ahead and prove that cosine to the fourth t minus sine to the fourth t all over cosine squared t. Prove that that equals to 1 minus tangent squared t. Okay, so definitely this side is looks more complicated than this side. Okay, so I'm going to go ahead and I'm going to choose the left. Okay, so cosine to the fourth t minus sine to the fourth t all over cosine squared t. Okay, so we've got these squares going on. So I'm going to be thinking, okay, at some point I'm going to be using the Pythagorean identities. Okay, so here I'm going to factor. So up in the numerator, I'm going to go ahead and factor because I have perfect squares. So this is going to be cosine squared plus sine squared times cosine squared minus sine squared. And then I have cosine squared down below. All right, and then here, sine squared plus cosine squared, this is 1, okay? So I get cosine squared minus sine squared over cosine squared, okay? I only have this left in the numerator because, again, this equals 1 from the Pythagorean identities. Okay, so this is what I have now. So I'm going to go ahead and separate these and write these as two separate fractions of each of them over cosine squared. So I'm going to rewrite this as cosine squared. Oop, forgot my t. Okay, cosine squared t over cosine squared t. And I'm going to write this one on its own over cosine squared. These two are equivalent, right? Because here I could combine these two fractions because they have the same denominator. And if I do combine them, this is what I would get. Okay, so I went ahead and split them up. This is 1, and sine over cosine is tangent. And this is exactly what we wanted. Okay, 1 minus tangent squared. Okay, 1 minus tangent squared. All right, so it's funny because, I did this. Okay, so one thing to keep in mind is that there are a lot of different ways to get to here. So long as you get to here, you're fine. Whatever work you did to get there is fine. It would be nice if you got here in the most efficient way, which is the least amount of steps. But sometimes it's not obvious. And maybe one of you will get it in a few steps, and then somebody else got it in 10 steps. Okay. So long as your final answer looks like the other side, you're fine. Okay. Like the first time when I did this, because I'm looking at how I did this problem earlier, and I didn't do it like this. I made it way more complicated uh, than this. Like I said, sometimes you see it and it's obvious, and sometimes you just don't. Like this one, 1, 2, 3, 4 steps. My problem has 1, 2, 3, 4, 5, 6, and mine has 7. All right. Okay. So I introduced secant. Yeah. Okay. All right. Let's try another one that's a little more complex. Okay. So let's go ahead and prove cosecant squared x minus 1 over cosecant squared x minus cosecant x equals 1 plus sine x. Okay, so I think this side looks more complex, so I'm going to choose this side. Maybe you try it too. Try it on your own, and then you can come back and see where you get stuck, and then see how I work out that trouble spot. Okay, so I'm going to choose the left side. And I have a bunch of squares, so looks like I'll probably be using one of the Pythagorean identities. All right, so let's see. We want to try to get to 1 plus sine x. Okay, so I'm going to start with factoring. Okay, so I'm going to go ahead and factor out a cosecant over here. All right, so I have cosecant squared x minus 1 cosecant x times cosecant x minus 1. Okay, so that's what I have. All right, so nothing cancels yet. You can't cancel these. These are not the same. But I could factor this because these are perfect squares. So the numerator will factor out to cosecant x plus 1, cosecant x minus 1. Difference of squares. All right, so now I can cancel this factor. Cosecant x minus 1, cosecant x minus 1. All right, and then I have cosecant x plus 1 over cosecant x. All right, and I can do what I did in the last one and split this up, right? So write the cosecant x in a fraction over cosecant x on its own, and do the same thing with the 1. And then here, this will give me the 1 that I want, and this will give me the sine x that I want. Okay. And so here I can stop because now it looks like the other side. Okay, so you just keep simplifying, 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 splitting things up if you can until you get there. Okay. All right, let's try this one. Let's go ahead and prove 1 plus cosine theta equals sine squared theta over 1 minus cosine. Okay, so the right side looks more complex to me, so I'm going to choose the right side, this side. Okay. All right, so sine squared theta over 1 minus cosine theta. All right, I have squares. Usually when you see squares, you're going to be using Pythagorean. I know sine squared plus cosine squared equals 1. So sine squared, I'm going to rewrite that as 1 minus cosine squared. That's from the Pythagorean. Okay. And then the numerator, I have perfect squares, so I'm going to factor that. 1 plus cosine theta, 1 minus cosine. And with that, I can cancel out the denominator. And now I have what is on the other side, 1 plus cosine theta. Okay, so a lot of this factoring difference of squares will come up. Okay, so keep that in mind. All right, I still have some more. I have 1, 2, 3, 4, 5 more examples. If you feel like you got the hang of it, you can stop and just start on the homework assignment. If you want to see more complex identities being proven, then continue watching until you feel like you've had enough. Okay. All right. So let's go ahead and let's try this one. Let's go ahead and prove that tangent x plus cotangent x equals secant x cosecant x. All right. Okay, I'm gonna choose the left side. Tangent x plus cotangent x. Sometimes if they're equally complex and you start with one side and you feel like you're not getting anywhere, maybe start the problem over and try starting with the other side. Okay. All right. So here I'm going to rewrite these using sines and cosine. So I'm going to rewrite this as sine x cosine x, and I'll see what I can do from there. So cosine x, sine x. All right. And now I'm going to add these fractions. So I'm going to get my LCD here, which is going to be cosine x sine x. So hopefully you know how to add fractions. Okay, so I need my denominators to look like this. They don't. This one is missing a sine x, so I need to multiply that first fraction by sine x. Sine x over sine x, which is 1, right? And then this fraction, I only have sine x. I want it to look like this. It's missing the cosine x, so I'm going to go ahead and multiply this by cosine x over cosine x, which is 1, right? That's all we could multiply them by, 1, written in the form of something else. All right, so I get sine squared x over cosine x sine x plus cosine squared x over cosine x sine x. Now they have the same denominators, so I can combine them. So I get sine squared x plus cosine squared x over cosine x sine x. Sine squared plus cosine squared, that's one of our Pythagoreans. Sine squared plus cosine squared is 1 over cosine x sine x. And this is the same as saying 1 over cosine x times 1 over sine x. And 1 over cosine is secant. 1 over sine is cosecant. And I believe that's what we wanted. Secant, cosecant. Okay. All right. Let's try another one. Let's go ahead and prove that sine theta cosine theta equals sine theta minus cosine theta all over secant theta minus cosecant theta. All right, so the right side is more complex. So we'll start with this side and see what we can do with it. Okay. All right. So, I'm going to go ahead and change these down here two sines and cosine. Okay, so secant theta is 1 over cosine theta. And cosecant theta is 1 over sine theta. Okay, so now I'm going to multiply everything. I'm going to multiply everything by cosine sine. Okay. And I'm going to do that because I'm trying to get rid of these fractions. So if I want to get rid of, if I need to get rid of this, I need to multiply by sine theta. And if I want to get rid of this, I need to multiply by cosine theta. But I have to multiply everything by that. Sine theta, cosine theta. And that way we get rid of these fractions. Okay. But then you also have to do it up here. So here you need to multiply this by sine theta, cosine theta. And this sine also gets multiplied by sine theta, cosine theta. Everything has to get multiplied. Okay, so in the numerator up here, I get sine squared cosine theta. And over here, I get cosine squared sine theta, or sine theta cosine squared, however you want to write that. Multiplication is commutative, so the order doesn't matter. And then down here, I get sine theta times 1, which is just sine theta. And here I get 1 times cosine theta, which is just cosine theta. All right, up in the numerator, looks like I can do common factoring, GCF. They both have sine in common. They both have cosine in common. So sine theta and cosine theta times sine theta minus cosine theta. And then here I get sine theta minus cosine theta. And now I can cancel these out. And I believe that's the right side. Oh, yeah, the left side, sine theta, cosine theta. That is what I wanted. So I can stop. Sine theta, cosine theta. Okay. All right. And so hopefully you are seeing some stuff that you can do when you're working through the problems. The thing is that the problems are also different. So, um, trying to memorize how I do these is not going to work. It's really the type of thinking that's required. And you only develop that kind of thinking by doing several different problems and really just being patient and working through them. All right, so sine alpha over 1 plus cosine alpha plus 1 plus cosine alpha over sine alpha. And I think this section really requires students to be strong in all of their math skills. If you're not, then you'll probably struggle like adding these fractions. So I remember when I took trig, and I loved this section. This was one of my favorite sections, proving identities. It's because it's like a puzzle, and you start with something, and you have an end goal in mind. Okay, all right. So clearly the left side is the more complex side. All right, so we are going to try to get this to look like 2 cosecant x. Oh, did I write x? Ah, it's not an x, it's an alpha. Okay. All right, so I am going to start by adding these. So I need the LCD. So the LCD is going to be 1 plus cosine x. I keep putting x, cosine alpha times sine alpha. Okay. All right, so I need to multiply I need to multiply this first fraction by sine theta, because that's what I am missing. And I need to multiply this one by 1 plus cosine alpha, because that is what I am missing. Okay, so now I have common denominators. So now I can, this is sine squared alpha, sine alpha, 1 plus cosine alpha. And here, this, I'm going to go ahead and multiply this out. That's going to give me 1 plus 2 cosine alpha plus cosine squared alpha, all over sine alpha 1 plus cosine. All right, they have same denominator, so I can add these together. Sine squared plus all of this, right? Sine squared plus cosine squared is 1. Here, let me, this plus this equals 1. Okay, so that I'm going to do this 1 plus 1 is 2. Okay, so I get 2 plus 2 cosine alpha over sine alpha 1 plus cosine alpha. All right, they have 2 in common, so I'm going to factor out a 2. I'll get 1 plus cosine alpha sine alpha times 1 plus cosine alpha, and these will cancel out. And so I get my 2 over sine alpha, which is the 2 cosecant that I want. Okay. Okay, so you can see here, if you have fractions, you want to try to add them. Okay, I think I have 2 more. I wonder how many of you guys are still here. Okay, all right, let's do this one. Prove 1 over 1 minus sine x plus 1 minus sine x cosine squared x equals 2 secant squared x. Okay, I think I'm going to stop here. Okay, I mean, I'm going to do this one, but I won't do the next one. All right, so I'm going to do the left-hand side. That looks more complex than the right-hand side. Maybe try this one and see if you're able to get this. What is it supposed to look like? 2 secant squared. Okay. All right. I'm going to go ahead and add these fractions together. So I need the LCD, which is 1 minus sine x cosine squared x. So this one's very similar to the last one we did. Okay. So this one needs to be multiplied by cosine squared over cosine squared. This one needs to be multiplied by 1 minus sine x over 1 minus sine x. All right, so let's go ahead and multiply these out and see what we get. All right, so we get cosine squared x over cosine squared x times 1 minus sine x. Over here, I'm going to multiply these out. So I get 1 minus 2 sine x plus sine squared x all over. That's if you FOIL, you got to do 1 times 1, 1 times sine. If you don't understand how I got this, you have to go 1 times 1, 1 times sine. Sine times 1, sine times sine. And then combine like terms. This is what you'll get. All right, and then here, cosine squared, 1 minus sine x. All right, I have same denominator, so I can add these two together. Just like in that last problem, I have cosine squared plus sine squared that equals 1. So I'm going to combine this one with this one, and I'll get 2. Okay, so I get 2 minus 2 sine x over cosine squared 1 minus sine x. And just like in the last one, I'm going to go ahead and factor out the 2 in the numerator. And I get this. And now I can cancel the 1 minus sine x. And I get 2 over cosine squared. And that is the same as 2 secant squared x. And that's what I wanted. That's what we have on the right-hand side. Okay. All right. So let's stop there. Hopefully that was enough examples to get you started. All right. So that is it for 5.1, just one video.